So here I have graphed x cubed, and that's this brown graph, x cubed. And then just to make it interesting, I came up with a new function, h of x, which is x cubed plus x squared. And that's graphed in black here. And you see it's got this little bump, which is the effect of the x squared. But the x squared term is overpowered by the x cubed term. And the x cubed plus x squared graph sort of looks like the x cubed graph, because x cubed has more effect in this h of x function. However, x squared makes itself known, and you can see that the graph is a little bit different. So then what I wanted to do is just review what happens when you multiply the function by -1. So we've got this black graph is our x cubed plus x squared graph, and that's our h of x. Now if you look at minus h of x, then you see that we get a reflection in the x-axis. So here's our black graph, x cubed plus x squared, and then look at the reflection. So this little bit is reflected right here, and this part is reflected right there, and this part is reflected right there. So each part of the x cubed plus x squared function, we see it reflected in the x-axis. Next, we see what happens if we look at h of minus x. So in this case, wherever you see an x in the h of x function, so x cubed plus x squared, you want to replace that with minus x. So we get minus x cubed plus minus x squared. And this gives us a reflection in the y-axis. So once again, we take a look at our x cubed plus x squared function, which is this black function, and then you can see that this part of the function is reflected right here in the y-axis. Here's the mirror, and this part is reflected right here, and this part is reflected right here, and this part is reflected right here. So you can see that h of minus x yields a reflection in the y-axis.